Proper evaluation of the acute burn, whether in the emergency department or in the outpatient setting, requires an understanding of the pathophysiology of burns. In this segment, we'll discuss the different types of burn and show examples of different types of burn severity. We'll also discuss a triage system for basic triage of acute burns.
The skin is the largest organ in the human body. It has two layers, a thin cellular epidermis derived from ectoderm, which overlies a thicker dermis made up primarily of extracellular matrix and derived from mesoderm. The layers of the epidermis include the basal layer, stratum spinosum, stratum granulosum, stratum lucidum, and stratum corneum. Other important cells in the epidermis are melanocytes, which provide pigment that protects skin against ultraviolet radiation, and Langerhans cells, which are phagocytes and antigen-presenting cells. Compared to keratinocyte regeneration, melanocyte replacement is slower and more unpredictable. Thus, even superficial burns can leave permanent changes in pigmentation. The dermis is, in turn, composed of two layers itself, the papillary and the reticular dermis. Cells of the dermis are primarily fibroblasts, which produce a highly ordered matrix of collagen and elastin. Fibers of collagen and elastin course through the ground substance, which is a mixture of glycosaminoglycans and proteoglycans. Unlike the ectodermal epidermis, the mesodermal dermis cannot regenerate after infancy, and instead heals by scarring and fibrosis. When heated, proteins in the skin are denatured and cells lose the integrity of their membranes. The amount of damage is proportional both to the temperature of the burn and to the duration of contact with the heat source. The classic burn presents with three zones of injury: the zone of coagulation in the center of the wound, where all the cells have died; the zone of stasis, with a mix of living and dead tissue, vasoconstriction, and ischemia; and the zone of hyperemia, populated with viable cells. The zone of coagulation is beyond repair, and the zone of hyperemia generally will survive, but only through careful management of the wound and the patient's comorbidities can the zone of stasis be salvaged. Burns heal when epithelial cells within undamaged follicles on the healthy edges of the wound migrate over the surface of the wound. These epithelial cells can divide and travel up to 1 centimeter to cover the burned area. These newly re-epithelialized burns are fragile, though, and new epithelium is prone to blister and desquamate.